This is a review of adding and subtracting fractions. This first example at the top of the screen is one of the easiest examples, and the reason for that is because the denominators are the same. That is what you want when you are adding or subtracting fractions. You actually cannot add them until they have a common denominator. So if you picture a pizza, pizzas usually have 8 slices. So you could look at this as, let's say, you took 1 out of 8 slices, and then your friend took 3 out of 8 slices. So you're figuring out what portion of the pizza has been taken out. When you are adding or subtracting fractions with a common denominator, the denominator does not change. So once I add, the denominator is still 8, and all I have to do is add 1 plus 3, which is 4. This should make sense. You and your friend took out 4 slices out of the 8, which is really 1/2 of the pizza. The way that you get 1/2 is you figure out what goes into both 4 and 8. 4 and 8 are both divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So make sure you always simplify your fractions if possible. The next example, I do not have a common denominator, so I'm going to have to figure that out. First, figure out, are 7 and 21 related in any way? I know that 7 goes into 21. 21 is 3 times 7. So I can go in and make both of these denominators 21. And the way I do that would be multiplying 7 times 3. Now, the rule with fractions is whatever you do to the denominator, you must do to the numerator. The reason for this is because 3 over 3 is really just 1. And anytime you multiply something by 1, you're not changing its value. I don't want to change the actual value of 2 over 7. I just need to work around it a little bit so that I'm able to add it to 8 over 21. But again, I'm not changing the value of this fraction. I'm just changing what it looks like, really. So we multiply by 3 over 3. 3 times 2 is 6. 3 times 7 is 21. And the same as before, now I can add the numerators because I have the same denominator. That denominator stays 21. And now I simplify. 7 goes into both 14 and 21. So I'm going to divide both numbers by 7. That would give me 2 over 3. Next, I'm going to subtract. It's the same rules as addition. If you look at this one, 5 and 4 are obviously not the same number, so I'm going to have to find a common denominator. Now, it's not like the last one. 4 does not fit into 5, 5 does not fit into 4, so this one is a little more involved than the last example. You need to come up with a number that 5 and 4 can both fit into. Well, 5 times 4 is 20, and 4 times 5 is also 20. So 20 is the number that I'm going to use because it is divisible by both 5 and 4. So in the first fraction, I'm going to multiply by 4, and I can't only do it to the denominator, I must also do it to the numerator. And same thing applies with the second fraction with the 5. So my first fraction, it's still a negative. 4 times 5 in the denominator is 20. 4 times 8, and the numerator is 32. With the second fraction, I have another denominator of 20, and this time the numerator is 45. Just make sure you bring down the correct signs. These were both negative. So for this one, I'm already starting at a negative 32, and then I'm getting more negative by subtracting 45. So you're really just adding these two numbers and slapping a negative sign in front. Negative 32 minus 45 is negative 77. And just like addition, the denominator doesn't change. Now, in some classes, you may have seen mixed numbers. In my class, I don't use many mixed numbers at all. So my students need to get used to improper fractions. So I'm going to leave it as negative 77 over 20.